Hi, class. We will be talking about Chapter 13, Water, a Limited Resource. Here is a quick overview of Chapter 13. We're going to be talking about the importance of water, water use and resource problems, water problems in the US and Canada, global water problems, what is water management, and how can we conserve water better. So you've probably heard this, but there is a huge water scarcity issue. And your chapter begins by talking about Turkana, Kenya. And in the picture, you see residents from a village that rush to fill their storage containers because there is a new borehole well that's dug about 60 meters, so almost 200 feet deep. And it's, up, it's um, a lot of water is coming out of it, so they're trying to fill it as much as possible. It is widely known that about 40% of the world's population experiences water scarcity. And in Turkana, people usually live on only 10 liters or 2.6 gallons of water a day, which is about half the minimum daily amount that the United Nations Development Program considers a human right. So we are really facing worldwide inequalities in terms of water resources. However, in 2013, new satellite radar technology that was funded by UNESCO, which is the UN Scientific and Cultural Organization, they located extensive underground reserves in Turkana, and that's why they are now drilling to pull out water and putting these wells. However, funding these technologies, and this is happening all around arid water lacking areas, funding these technologies is very difficult and can be expensive. So we all know that water is probably the most important resource on this planet. However, all living organisms can mostly just use fresh water, and fresh water constitutes only 2.5% of water on Earth. And with increasing population, there is an increase in demand. 97, that means that 97% of water on Earth is salty and it's not available for use by most terrestrial organisms. Water has a tremendous effect on our planet. It helps shape continents, right? Through erosion and deposition. It moderates our climates, obviously through the hydraulic cycle, and it allows organisms to live. We all know that everyone on Earth needs water, and so do most organisms in order to metabolize and have energy. What are some of the properties of water? So let's dive in and really understand what water is. This is a little bit of a chemistry. It's composed of molecules of H2O, which is 2 hydrogen and 1 oxygen. It can exist in any of the 3 forms of matter, solid, liquid, or gas. And the water molecules are actually polar, which means that one end of the molecule has a positive electrical charge and the other end has a negative charge, right? It creates this charge through through two hydrogen bonds, right? And that's how it can really connect to each other. Water can absorb a lot of heat, and after it absorbs a huge amount of heat, it vaporizes, right? Evaporation. And this is called the heat of evaporation. It is also considered to have a high heat capacity because of this. And that's why it can moderate the climate. And water is sometimes called the universal solvent. What does that mean? Well, many materials do dissolve in water, and that's why in nature, water is almost never pure, as you can see here. So now let's talk a little bit about actual salt water. In 1 kilogram of salt water, you have, 965 grams of water, but then you have those 35 grams of salts that can compromise of potassium, calcium, magnesium, sulfate, sodium, and chloride. Um, this is very important because these minerals are sometimes essential to certain organisms, and thus being able to easily be dissolved in the salt water makes salt water very important. Climate change, water dissolves many chemicals that can act as pollutants. So one interesting fact is that in the past, before the 1970s, people regarded pollutants thrown into the water as just not a big deal because it would just, be dissolved and disappear. That's not what we have seen now. But some people still think that just throwing chemicals and pollutants into the water is fine. Climate change is reducing fresh water in ice caps, which is very significant because it's being lost now in seawater. And making it more fresh could dilute salt water. And that's why this question is, how will this affect the composition of salt water? Will we expect those other ions and elements to basically be reduced in the overall content of salt water? The distribution of water is very uneven, right? As I mentioned, less than 2.5% is fresh water, and 2% of it is in the form of ice and ice caps and glaciers, etc. That means there's only 0.5% of water on Earth as available fresh water, okay, that we can use. And some forms of fresh water are used preferentially, which we'll discuss. Groundwater here in South Florida is very important and used over lake, river, soil, water, okay? Here is some freshwater terminology that you might want to take note of: surface water, runoff, drainage basin, groundwater, and aquifer. The definitions are pretty self-explanatory, so I am not going to go into them, and I'm sure you've heard them in the past. So to continue, watersheds, or also known as drainage basins and catchment basins, are very essential for water access around the world. They're basically areas where there's a large amount of water underneath, as well as provided through rivers, etc. Here you can see the world's 10 largest watersheds. A lot of people know the Nile River as the longest river on Earth, but by volume of water, it's actually the Amazon River which holds the most water. Because if you were to look at the entire Amazon River basin, it's quite significant and really insane. I highly recommend everyone look it up because it covers almost between 1/2 and 2/3 of the entire South American continent. Watersheds and groundwater. So here is where you basically understand the components of a watershed. When excess surface water seeps downward through the soil and porous rock layers until it reaches impermeable rock or clay, it becomes the aquifer, right? And the water table is the upper surface of the saturated zone of groundwater. You can see that here we have that runoff excess water, stream and lake, the infiltration to the left of those water sources that then becomes part of the aquifer. And then you see these artesian well as well as the water table well, which allow for people to pump out water to be used. And we actually use aquifer water here in South Florida. Moving on to water use and resource problems. This is going to be very important for all of you to understand. The greatest user of water worldwide is agriculture. Irrigation accounts for 70% of the world's total water consumption, industry 19%, and domestic and municipal use about an 11%. So water problems fall into three categories: too much water, too little water, and then contamination of water, which will be addressed later on. Too much water. Well, as we saw with hurricanes in the past, flooding is a big issue. It's both natural and human induced. And you'll see how it can be human induced, not just like a hurricane or a storm. Modern floods are very destructive, okay? They're showing to increase intensity and are resulting in property loss, removal of water absorbing plant cover from the soil, and cannot be caused by constructions of buildings on floodplains. But what is a floodplain? Well, a floodplain is an area bordering a river channel that has the potential to flood. Let me show you how pre-urban versus urban floodplains happen and can affect what occurs during a flood. Pre-urban, you would have 100% precipitation is falling down, right? 40% would stay on the surface and be evaporated and transpired, right, through plants, and 10% would become surface runoff, because since most of the trees absorbed, and then there's also evaporation, it was able to contain a lot of the water up there. So we only have 10% surface runoff. And then the rest would be absorbed through the natural soil as groundwater, so 50% groundwater. Now, when we start building on floodplains, which often has happened, this gets very messed up. The construction of impermeable surfaces such as buildings and roads, well, it blocks it from completely being able to be transpired and or absorbed into as groundwater, right? So that's a huge problem with concrete roads. And that's when we have a larger percentage of surface runoff that can become flooding. So floodplains, as I explained, are areas bordering a river channel that has the potential to flood. And by increasingly building on floodplains, we increase the likelihood of a flood and the intensity of the flood to damage properties, to harm wildlife, to harm plants, etc. With people noticing that building on floodplains has become a problem, there are now instituted government restrictions on building, particularly after Katrina in 2005, where we saw all these levees failing around the Mississippi River Delta to contain the storm's impact. There are now restrictions on the floodplain building. So flood management with river channels or levees. So to the left, levees are adjacent to the channelized river, right? So there are these long, basically mounds that are sloped inward, so that when these channelized rivers start to rise, the water does not leave. However, what we have seen is that it can still, since you are creating a straight path, and that's not how rivers normally behave, right? They're not in a straight line. The flooding can still get out of control. Today, levees are primarily, they allow rivers to meander, and then there are smaller levees set on the back of the floodplain. So allowing the river to have more space to flood, and then having those levees towards the end of the floodplain. And I would call this, a nature-based solution in which we have really seen construction and engineering change from just demanding the land or controlling the land to be a certain way, to understanding the land and trying to work with it and seeing that, okay, it has to flood because that is how this river behaves. Why are we going to divert and change the course of the river? Let's just change where we put the levees. Mississippi, the floods of summer 2011. Now, the Mississippi River is the longest river in the United States of America. It spans 31 states and 2 Canadian provinces, and it floods frequently. In 93, the flood involved farms and towns in 9 Midwestern states, spreading over 9.3 million hectares and causing an excess damage of $12 billion. In late spring of 2011, there were unusually high rains in the upper reaches of the floodplain, coupled with abundant snow melt from those northern Canadian provinces, which resulted in massive amounts of flooding. We saw flooding in Illinois, Missouri, Kentucky, Kansas, Tennessee, Mississippi, obviously, and Louisiana. It affected more than 43,000 people and caused approximately $2.8 billion in damage to 21,000 homes and businesses. There have been an elaborate flood control system built along the Mississippi that was controlled by the Army Corps of Engineers. It was the world's largest, with lots of levees, floodways, spillways, pumps, and reservoirs. However, those levees failed, okay? Those levees failed. And although, they did fail, they did prevent a lot of more catastrophic flooding. So it was both a savior and a lesson in a sense. And so now there is debate over the degree that the river should be altered and how much building there should be in the floodplain. However, as we know, and as you can see here in this map, there are several towns, cities, municipalities. There's just a lot of people living along this river. So, and to say that we can no longer inhabit this area is not possible because there's just people have been living there for hundreds of years, and New Orleans and Memphis and St. Louis are major cities, and so we cannot just say that's it, everybody needs to move. So there needs to be better solutions, and that's one of the problems facing the United States. Army Corps of Engineers, as well as other natural resource agencies. Now we're going to talk about too little water. I don't know if you guys heard me mention, but arid lands or deserts have frequent or prolonged droughts, right? And how does this happen? Well, the overdrawing water for irrigation, which I mentioned earlier, which is becoming increasingly more and more because of worldwide efforts to produce enough food for an never-ending increasing population. And also, there's just areas that don't receive enough rainfall to replenish their aquifers. And what happens is that the land, the subsidence can collapse into sinkholes and really just degrade overall. Another big problem of too little water is saltwater intrusion. And this is an important topic for right here in South Florida. Since we are pumping fresh water from our Biscayne aquifer at, a high amount to give fresh water to all of our residents, it is depleting the water table and allowing for this cone of depression to move up and allowing ocean water and salt water to enter the aquifer. So, it's all based on human demand. And we are here in South Florida, we are very concerned about what will happen with increased saltwater intrusion into our aquifer. How will we give fresh water to all of our residents? In reality, though, the US has a lot of plentiful supply of water, fresh water. We have mountains and several aquifers all along that are easily extracted from. Mountains that provide glaciers and ice caps. So we actually have a lot of water. However, the uses of water and specific geographical areas that contain arid or semi-arid lands can face severe shortages. One that a lot of people have heard of is the droughts that occur in the West and the Southwest US. Water is constantly being diverted and transported via aqueducts. This area is arid, semi-arid. And historically, because of that Mediterranean-like weather, a lot of the water that has been diverted is used for irrigation. Particularly agriculture. One good example of surface water shortage is Mono Lake in Eastern California. There were rivers and streams that once fed this lake, right? And then an extensive aqueduct system was built to divert water from the lake to the burgeoning metropolis of Los Angeles, which is 275 miles away. However, because so much extraction from this lake occurred, it left behind a lot of salts, which then allowed for the lake to become hypersaline. And I believe in the 2000s is when they finally realized uh, that they could not keep pumping water, at such a high level to allow the freshwater levels to increase. Um, and then in 2017, with heavy rain and snow events, the levels of water at Mono Lake finally began to increase. The other big and actually a very multi-state water shortage problem is the Colorado River Basin. It provides water for 35 to 40 million people. Its headwaters are formed from snowmelt in Colorado, Utah, and Wyoming, and it extends through Arizona, Mexico, Nevada, and California before it empties into the Gulf of California. So it's a pretty big deal as well. And there have been numerous dams, including the Hoover Dam, which a lot of people know of, to produce hydropower, to create drainage basins and mini lakes. One of the most important treaties that regulate the Colorado River is the 1922 Colorado River Compact, which stipulates an annual allotment of 7.5 million acre-feet of water to the lower Colorado, aka California, Nevada, Arizona, New Mexico, and the remaining to the upper Colorado, Utah, and Wyoming. However, the Colorado River Compact overestimated the average annual flow of the river, which at the time was thought to be 15 million acre-feet. This over-allocation was enshrined in the multi-state agreement. Mexico receives a share of the Colorado River as stipulated by a 1944 treaty. However, it has been shown that after passing through all of the United States, it is now very salty. The water is very salty and quite low. It's just really sad. And here you can see a picture of the Colorado River Delta at the Gulf of California, because water is diverted and extracted so heavily that it barely reaches the ocean and it dries up. This is not normal, and this is very unfortunate. Scientists have predicted that climate change could lead to a 10 to 30% less flow in the Colorado River within a few decades. That's already terrifying, considering this is what it is now. So it's just going to keep decreasing. Lake Mead and the Hoover Dam will be affected by this. And in 2014, engineers installed turbines that function more efficiently at low water levels, because we've already seen the decrease in the water capacity of the Colorado River. We also have groundwater. Roughly half of the population of the US uses groundwater for drinking. This includes Tucson, Miami, San Antonio, and Memphis. However, 40% of the groundwater used for irrigation comes from 40% of the water used for irrigation comes from groundwater, and many areas where removal has been done has resulted in saltwater intrusion, like right here in South Florida. So what are some of the global water problems? Well, as we know, data on water availability indicate that the amount of fresh water on the planet is adequate to meet human needs, even taking human population into account. However, we know that the distribution of water resources in relation to human populations is not feasible, right? And right now, the biggest problems globally related to water is weather, climate variation, need for clean, consistent drinking water, population growth, and sharing water resources among countries. Water and climate. Climate change has definitely, and that you guys need to know this for your exam, climate change affects the type and distribution of precipitation, right? Changes in rainfall may lead to abrupt changes in available surface water, since runoff is influenced by geological factors such as soil permeability and biological factors such as the amount of vegetation. There have been studies that show that the 10% decrease in rainfall in one part of Africa would lead to a 17% reduction in runoff, while the same precipitation decrease in another area would lead to a 50% reduction in runoff. So the distribution changes, and we will see how climate change will affect the hydrologic cycle. Drinking water problems. I'm sure you guys have all heard, but a lot of the inhabitants of developing countries have insufficient water needs that are met, right? This is also due to the lack of proper distribution. So it's around 663 million people that lack safe drinking water. And as we know, 80% of human illnesses that are common occur because of poor water quality. And that's a statistic from the World Health Organization. Nearly 1,000 children are estimated to die each year as a result of diarrheal diseases that are caused by contaminated water and poor sanitation. Population growth has definitely is an influencing factor in water quality and drinking water. Increase in population means an increase in fresh water needs, which limits drinking water available, which limits water available for agriculture and food. And it also means that less water is available, so the quality can significantly decrease. Global water stress. I really like this map. You don't need to remember it or anything, but it just shows you the ratios of withdrawals to supply, meaning that they have been able to compare how much is being extracted with how much there actually is. And that's how you calculate the stress level. Um, in the US, we have a medium to high stress, right? Because we have a very large population with a lot of demands. Places like India with over 1 billion people, they have high stress because low levels of supply or mid to low levels of supply, but with a huge population. Look into Northern Africa and the Middle East, these arid regions, we know definitely have lower supplies due to the lack of precipitation, and yet their population keeps increasing as their countries become more developed. So, great map, great visual. Take a minute to look at it, analyze it. I think it's really revolutionary what it's showing. Another big conflict is sharing water resources among countries. We talked about the Colorado River Basin and how the states above and below Colorado, and even Mexico have to basically have come into a treaty to share the water. It's not being very successful because obviously the delta is drying up and water is not even reaching the ocean. Another good example that your book talks about is the Rhine River Basin in Europe. It's going through 5 highly developed and densely populated countries: Switzerland, Germany, France, Luxembourg, and the Netherlands. And traditionally, Switzerland, Germany, and France use the water for industrial purposes and then discharge polluted water back into the river. The Netherlands, which in 2010 got 82% of its water from its borders, had to clean up the water so its citizens could drink it. That became a huge problem, and in 1950, the 5 countries formed the International Commission for Protection of the Rhine, right? River quality did begin to improve in the mid-1970s. However, in 1986, a severe chemical spill in Switzerland dumped 30 tons of dyes, herbicides, fungicides, insecticides, and mercury into the river. The spill galvanized the International Commission for the Protection of the Rhine, and it was able to kind of clean up a lot of the pollution. Currently it's considered a successful international cooperative agreement. However, we must take into account that these nations are highly developed and are able to put funding into such types of agreements. When you have lower socioeconomic, lesser developed nations sharing a water resource, this might not be exactly possible without the financing or funding from outside more developed nations. So this is very rare. I want to stress that because we know that the Western, more socioeconomic developed nations are able to do this sort of thing. This is a good example of probably lesser developed nations and the exploitation of a water body to the point where it is now disappearing. Similar to Mono Lake, the Aral Sea straddles Kazakhstan and Uzbekistan, which are former nations of the Soviet Union. With the collapse of the in the 50s, the Soviet Union began diverting water from the Amudarya and the Sirdarya, which were the 2 rivers that feed into the Aral Sea to irrigate surrounding desert areas to create agricultural lands. Because of this, once the world's 4th largest freshwater lake, the Aral Sea had declined by more than 50% in 2000. And at one point, its total volume was down as much as 80%. A lot of its biological diversity has disappeared. All 24 fish species found here are gone. There are about 35 million people who live in the Aral Seas watershed, and a lot have started developing health problems from tuberculosis to severe anemia because the lack of dilution from the water leaves these basically toxic minerals and elements that are in high quantities can affect human health. There are plans to improve the Aral Sea, especially after the fall of the Soviet Union, which only exacerbated the condition of the Aral Sea because Uzbekistan and Kazakhstan did not have the government direction and government help that they had received previously from Moscow. So currently, there is a project sponsored by the World Bank that is called the Syrdarya Control in the Northern Aral Sea Project, which includes ecological restoration and commercial fish recovery. It's very slow, and what we have seen is that there have some improvements, yet the Southern Aral Sea has not had any restoration efforts. It has become saltier, and in the eastern part of the basin, because of this, it has completely dried up. So it's very unfortunate. As you see, the northern and the Sardaya, which is to the west, has been able to receive restoration. But it's crazy to see the difference between 1976 and 2016. Water management. Water management is very fickle because it might be, the most important resource that we have on this planet, yet people don't take its importance into account and kind of treat water as a, take as much as possible. Okay. It's not like gold or coal that is usually owned privately and sold as a free market good. Water is viewed as a public resource, and that is good and bad because we have just so much exploitation. Water, as we have seen, is also a transboundary issue that requires cooperation and permits between different agencies and between different nations. And even management challenges between the types of water can vary from surface water compared with groundwater. However, what scientists and resource managers have established is that the main goal is to provide a sustainable supply of high quality water. That is always the goal. Has it been possible in all instances? No, but that is always the goal. And sustainable water use is extremely important because it's use that does not harm essential functions of the hydrologic cycle or the ecosystems on which present and future humans depend on. The main goal, as I said, was high quality water. I am not a big fan of dams and reservoirs, but we will discuss them. So dams ensure a year-round supply of water in areas with seasonal precipitation or snowmelt. Dams confine water in reservoirs from which the flow is regulated. Many people, however, have noticed that there are several drawbacks to dams, including environmental costs that they say by far outweigh the benefits that are provided by dams. And some of these they alter the ecosystem, right? So fish are not able to migrate properly or move freely, and they reduce sediment load. As I've mentioned, water changes land, right? The Grand Canyon was not solely carved by wind, it was carved by water as well. The movement of water changes land. And so by blocking the flow of water, through a dam, you are not allowing for sediment to move along, right? So what we usually see in a reservoir is a buildup of sediment here and high water, and these areas do not receive sediment or enough water flow. This has happened in the Glen Canyon Dam, which is a dam along the Colorado River. In Grand Canyon National Park. So historically powerful springs, um, brought sediment, and then these created these sandbar habitats that were essential for wildlife reproduction and habitat. Think about it. These sandbars were areas were small areas that animals could go drink water, could mate on, could be used as temporary shelter, not shelter, but like areas to stay on near the water so that they could easily access water. And because of these sandbars, you would only have a thin layer of sand on the river floor. But with dam construction, we have seen the loss of these sandbars. And the loss of sandbars means a loss of habitat. Now we're seeing just a thick layer of sand on the river flow because the sand's not accumulating on the sides, it's accumulating on the bottom. To fix this, the US government has instituted a natural resource management plan that allows for periodic flooding to allow the restoration, the restored sandbars starting in 1996. And they do more frequent pulses or releases of waters to allow the sediment to create these restored sandbars. But what you see during those releases is that the water is very turbid and it looks dirty because of course it has a bunch of sediment, and then after it settles, it becomes those restored sandbars. Another water management issue or water management plan is water diversion. Similar to Mono Lake in California, water is diverted into water is diverted into different areas for long distances through a system of aqueducts. This is considered controversial and expensive because we are basically playing God with our water sources. There are some areas that are not meant to have water like this, okay? And probably not meant to have human inhabitants, yet we have forced ourselves to live in these areas and create agricultural lands. So it's not a sustainable and feasible option. Desalinization, as I mentioned, seawater and salty groundwater is starting to occur more often due to saltwater intrusion. And one of the solutions is desalinization, which is the removal of salt. And it happens through two methods: distillation, which is salt water is evaporated and the water vapor is condensed into fresh water, and reverse osmosis, which is basically forcing salt water through a permeable membrane, but the salt actually stays back, so those mineral salts stay. It is very common in the Middle East and Africa, but it's so expensive and it requires high energy, which then goes back to, renewable versus non-renewable. Water conservation. This is probably my favorite topic. So as we have seen, population and economic growth have placed an increased demand on the Earth's water supplies. But how can we become more sustainable? How can we conserve our water resources? Probably the biggest and most important way, and you may have heard of this, is reducing agricultural water waste. Agriculture is very inefficient with water. sometimes they are pumping way over the amount needed for water for a plant. And just to let you know, plants absorb about 40% of the water applied to the soil by flood irrigation, and then the rest usually evaporates, right? And so that's a loss that is ridiculous. Um, this really cool innovation called micro irrigation or drip or trickle is where a pipe has tiny little holes that can send water out little by little. And you can see this here, the trickle micro irrigation system. It feeds it directly to the roots, which will then be absorbed and not lost through evaporation or runoff. New technologies. Excuse me. Low energy precision application irrigation and geographic information systems. So WIPA actually involves dragging hoses across fields in a computer controlled pattern. Super cool. And the water is only released where needed. GIS uses signals from satellites to identify locations where irrigation is needed. So areas that have high drought or where they're noticing a lot of yellowing or dying plants that may need it. It's been so successful that in Texas, it's actually helped decrease water use by 8-fold. So that's pretty massive. Industrial waterways has also been a big thing. The way that we have reduced it is through using used water in industrial activities is through power generators, right? But now stricter pollution control laws provide some incentives for industries to conserve water. Industries are now required to recapture and purify and reuse water for their use and their water treatment. In 2010, Jackson Family Wines in California implemented a water recycling system that allowed the winery to save up to 6 million gallons of water, which is amazing. And then in 2015, they launched efforts to restore diminished creeks and populations of juvenile trout and salmon by the nearby creeks. So a lot of people think that companies and industries cannot survive sustainably with nature, but this is a great example of how, you know, a winery saw how much they were saving on water usage, and then through their water treatment, through their water recycling program, and then decided to start restoring the nearby creeks. And so it's truly amazing that something that is saving them, probably money as well, resulted in saving the ecosystems around them. Recycling municipal water. I don't know if you guys have ever heard about gray water, but it's basically water that's already been used in sinks, showers, washing machines, and dishwashers, and then it is filtered through the toilet to be reused, and then there is a gray water storage. So if you look at the picture, you know, you use it in the shower, you use it in the sink, and all that water goes down to the gray storage tank, which then goes back up into the toilet. And then, you know, you defecate, you urinate, and then it gets pumped back out to be used in lawns or other ways. It's really a water saving initiative because we're just reusing water that isn't necessarily completely dirty, you know, with waste or fecal matter. So it's pretty good. Here are some examples of how you can practice water conservation. And read this over, but my favorite one is the second to last one, which is also depicted here in the picture on the right. Outdoor xeriscaping, okay? Not landscaping. Traditional lawns are horrible. Just having grass lawns with 1 or 2 trees are horrible. The grass that is commonly used in lawns is not native to South Florida. It's crabgrass, and it's just not very good. Um, if you really want to help conserve water, lower your cost for water, help out the environment, provide habitat for wildlife, increase pollinators, you need to try xeriscaping, in which you use native plants from the area that you live in to landscape and create a beautiful habitat for plants, animals, and then conserving water, because usually these plants are adapted to surviving in your environment and thus don't need a great amount of water, unlike grass, which is not adapted to that area, well, the specific species of grass, and then can require you to install a ridiculous lawn irrigation system. So I'm very passionate about that, and everyone should definitely look into how they can turn their lawns into a native landscaping, low water waste place. That's it for now. I'll see you guys in chapter 14.